What's going on, everybody? In this session, let's talk about derivatives, which is a concept that you can think of as a rate of change, right, depending on or based on a function or the slope, as we previously discussed. Okay, and so when we're talking about derivatives or rates of change, the easiest way to talk about this is first recalling, right, that we know that functions generally come in the form of y as a function of x, and that f of x is just a math equation, right? Like 2x plus 3, right? Whose output, f of x, depends on where we evaluate x at, right? In terms of if we evaluate x at 1, we get 2 times 1 plus 3, which is 5. If we evaluate x at a different value, you'll get a different value. And so let's take what we know about a function and let's think about this in terms of position, okay? So we're going to think about functions in the context of position, meaning a math equation that represents your position, right, as a function of time, okay? So let's take our f of x function and let's just rewrite this so it's a little more intuitive. I'm going to write the same thing just using different letters. So instead of f of x, right, we're going to interpret this as position with respect to time is equal to 2 times t plus 3, where t, right, t represents time. And let's say the time is in seconds, just for this example, okay? So now that I've given you the position function, at any point in time, right, you can calculate your position. If I were to ask you now to go from position and I wanted you to calculate, right, your change in position with respect to time, right, respect to time, what I'm asking you for in this case is what we call velocity, okay? And so this is a key term to remember, as well as position, okay? As well as position, and I have it written on the left as well, okay? And so in order to go from position as a function of time to velocity as a function of time, we need to do something called take the derivative, okay? And mathematically, in order to take the derivative, right, or find the rate of change, you're going to follow this general formula, right? And so if I give you a function, so in general, let's write this down, right? The derivative of a function, we'll call it f of x, right? That's what we're used to seeing. You can calculate this, or is calculated, sorry, is calculated, right, as follows. And so the notation is this: the derivative with respect to x, right? So we're taking the derivative with respect to x of our function f of x, right? So the derivative with respect to x of our function f of x, right? And here's a shorthand way of writing that is f prime x, right? So the derivative of f of x, right? So these two terms are equivalent. So you can write whichever one is more convenient for you, right? And so the derivative of x can be calculated by taking the limit as h approaches 0. And if you need to brush up on limits, check out that last video that we worked on, right? Of f of x plus h minus f of x all divided by h. Okay, and we're going to look into what this means. So essentially, this is your definition of a derivative or rate of change. All right, and this is what we're going to use to practice today. So the best way to learn this is, for me at least, through an example. So let's take as an example, right, the function that we all know and love, the parabola. F of x is equal to x squared. Again, this is your parabola, right? And let's say I want to take the derivative or find the rate of change, right, of this function, okay? Cool thing is, we've been talking about derivatives in terms of rate of change. When you take the derivative, this is also a way of calculating your slope, right? Because slope is the rate of change of this function, okay? And so let's use our definition of a derivative to derivate this function. So the derivative with respect to x, right, of our function f of x is, and we'll just write the shorthand notation here, right, and you can select whichever notation you like, is equal to the limit as h approaches 0, right? This top part, f of x plus h. What this means is, in the function that you're working with, right, in our case, it's x squared, wherever you see x in here, right, which is only here, you're going to replace that with x plus h, this entire term. So for f of x plus h, you're going to get x plus h squared, right? Because all you did was you replaced x here with x plus h. So now the next term is minus f of x. This is just your original function. Our original function is just x squared. We're going to divide all that by h, all right? Now let's simplify and evaluate what we have here. And keep in mind, you always want to keep track of this term here, the limit as h approaches 0, because sometimes h will end up in your final step and you're going to have to plug that in, but not right now, right? So x plus h squared is going to look like this if you haven't seen it before, right? So x plus h times x plus h minus x squared, right? All divided by h. In order to evaluate this right here, x plus h times x plus h, we're going to use a method called FOIL, okay? And this stands for first, outer, inner, and last. And what this means is, when you're evaluating this function, and we'll do it up here, the first terms that you multiply are going to be your first terms. The f stands for first. So the first term in this one is x, the first term in this one is x. So you're going to get x times x, right? Plus, now you're going to multiply the outer terms. So outer term here is x, right? The left outer. The outer term here is h, right? It's on the right edge. So x times h. Plus, now you're going to do the inner terms, right? So in this case, in this first term, h is your inner term. In this case, x is your inner term. So h times x. And then L stands for last. So the last values in each of these. So h times h. Okay. And when you simplify this, this becomes x squared, right? Plus xh plus xh plus h squared. This and this can combine, right? So you're going to end up getting x squared plus 2xh plus h squared. All right, so now let's plug this, right, into its spot. So we're going to just plug this back in here, and we're going to keep this thing going. So this is going to be equal to x squared plus 2x h plus h squared, that's this whole term, minus x squared, right? All divided by h. Now you're going to look for similar terms to cancel. X squared minus x squared, that goes away, okay? Now you're just left with these terms here. And you can break these up, right, into this first term over h plus this second term over h, right, because they have a common denominator. And so this is going to turn into 2xh, the first term, over h, right, plus the second term, h squared over h, okay? And so you're going to cancel these. You're going to cancel one of the h's here. And so you're going to end up, and I've been forgetting my trusty rule, the limit as h approaches 0, 2x plus h. 2x plus h, right? Now you're going to plug in your h is equal to 0. You're going to end up with 2x. Okay? So this is the derivative with respect to x of your function, right? And for us in this one, our function we were working with was our trusty parabola, all right? So pause the video and take a look if you need a second. If not, let's do another example, okay? So let's do another one. So let's say I give you the function f of x is equal to 3x plus 2. We've all seen this one before as well, right? And so remember, if I'm asking you to find the derivative, right, with respect to x of the function f of x, right, this is the same thing as the shorthand notation. Pick whichever one you like. And to do this, we are going to follow, right, the definition of a derivative, which is what? The derivative of a function f of x is equal to, right, f of x plus h minus our original function, all divided by h. And so let's keep using it and writing it down until we know it by heart, right? So let's use this to evaluate our function 3x plus 2, right? So f prime x, the derivative of f of x, is equal to, remember, f of x plus h, right? We're going to look at our function, and wherever we see an x, we're going to replace that with an x plus h. So in here, you see an x right here, right? So for this term, it's going to be 3 times x plus h plus 2, right? This entire thing is this term, f of x plus h, right? Now we're going to subtract our original function. So just this entire thing, 3x plus 2, minus, right, 3x plus 2. And note that I put these in parentheses or brackets because since you're subtracting an expression, you're going to have to remember you need to distribute this negative, right, to each term inside. Okay? And then all this is divided by h. So now let's work it out and simplify. So same thing here. You're going to have to multiply, right? Distribute the 3 to each of those terms. So you're going to get 3 times x, right, which is 3x, plus 3 times h, which is 3h, plus 2, minus 3x, because a minus, and this is positive, a minus and a positive make a minus, minus 3x. Same thing here, a negative and a positive make a negative, so minus 2. All that divided by h. Now let's look for like terms, okay? 3x minus 3x, that goes away. 2 minus 2, that goes away. Now all you have left is 3h over h, right? The h's go away, and this is going to give you 3. All right? And so in this case, you found that the derivative with respect to x of your function, right? In this case, our function was 3x plus 2. That derivative turned out to be 3. All right? So if you got it up to this point, good job. If you don't, pause the video and try to look at steps that we took to kind of get here, right? So all the work that we're doing is based on this formula right here, right? This is the formula of the derivative, or the definition of the derivative, right? Let's recap. F of x plus h just means that you're going to look at the function you're working with. In our case, it's 3x plus 2. Wherever you see an x, right? So you're basically evaluating this at x is equal to x plus h. So wherever you see an x in your function, you're going to replace it, right? Kind of like how we did here with an x plus h, right? X plus h. F of x is just your original function. So this is just your original function, 3x plus 2, right? But when you're subtracting an expression, we said you have to remember to distribute the negative to each term inside, right? We're going to simplify, and then we got it down to this point, okay? And so let's do one more example, and this time, make sure, I'm not sure if you guys have been doing this, but try it out, right? And I'll write it down here. After I write this down, you try, and then we'll go over it together, okay? So f of x is equal to 5x plus 7, okay? So find the derivative with respect to x, right? Because x is our input of f of x, okay? So take a second to do this if you'd like. And just a quick tip, if you haven't paused it yet, remember we're going to use this definition of a derivative, right? So derivative of a function x is equal to f of x plus h minus the original function all over h, okay? So go ahead and give that a try. Awesome. So let's go over what you were supposed to do, all right? So this is our function, 5x plus 7. And this is the definition of a derivative that we're going to use to find the rate of change, right? Because remember, derivatives are rate of change, or more familiarly, right? It's the slope of your function, okay? And so the derivative of the function f of x is equal to f of x plus h wherever you see an x, right? You're going to evaluate, or you're going to plug in x plus h. So in here, it's going to be right there. So for your first term, it's going to be 5 times x plus h plus 7. And let me get rid of that right here. So this is going to be this first term, f of x plus h, minus the original function. So minus 5x plus 7. Remember to draw the brackets so you don't forget. Distribute your negative. All of this over h. Now, let's get the simplifying. So, same thing with this 5, right? So we have 5x plus 5h, right, plus 7. This is going to be this left term here, minus, right, a minus and a plus makes a minus. Minus 5x minus 7, because a minus and a plus make a minus. So minus 5x minus 7 all over h. Let's figure out what terms we can cancel, right? Like terms. 5x minus 5x, gone. 7 minus 7, out of there. All you're left with is 5h over h. Okay? 5h over h. Top and bottom are the same. This goes. That leaves you with 5. Okay? And this is the derivative with respect to x of your function f of x, right? And in this case, your function was 5x plus 7, okay? And that was equal to 5. Okay? So if you understand this, fantastic. If not, then try practicing a little more and see if you can't catch the pattern, okay? And remember, all this stuff is coming from the definition of the derivative, okay? So for any questions or comments, please feel free to leave them below, and I'll get back to you as soon as possible, okay?